The American engineers expected to find junk, crude Soviet copies of Western technology held together with inferior materials and communist shortcuts. When they finally cracked open the MiG-21's radar system at a classified facility in the Nevada desert, what they discovered instead would shake the foundations of American military planning and reveal a terrifying blind spot that could have lost them a nuclear war. But to understand what those engineers found and why it mattered, we need to go back 2 years. To an Iraqi fighter pilot trapped between his conscience and his country. To a Mossad operation so audacious that it would remain classified for decades. And to a single morning in the summer of 1966, when a lone aircraft descended through the haze over Israel's Jezreel Valley, carrying secrets that would change everything the West thought it knew about its most dangerous adversary. This is that story. To understand why the West was so desperate to obtain a MiG-21, we must first understand the state of aerial combat in the mid-1960s. The United States had entered the conflict in Vietnam with supreme confidence in its technological superiority. American aircraft were products of the most advanced aerospace industry in the world. American pilots were the best trained flying machines equipped with sophisticated radar systems, guided missiles, and electronic countermeasures that Soviet bloc nations supposedly could not match. The reality of combat shattered these comfortable assumptions with brutal efficiency. Over the skies of North Vietnam, American pilots began encountering an enemy that refused to follow the script. North Vietnamese pilots, many trained by Soviet instructors, flew their MiG-21s with skill and aggression that caught American forces completely off guard. The sleek Soviet fighters would appear suddenly, streaking through formations of American aircraft, firing their missiles and cannon before disappearing back into the clouds. Hit and run, hit and run. The tactics exploited every weakness in American doctrine. The loss rates were shocking. In 1965 and 1966, the exchange ratio between American and North Vietnamese aircraft was far worse than anyone had predicted. American pilots were being shot down at rates that caused genuine alarm among military planners. The vaunted technological edge seemed to evaporate when confronted with this mysterious Soviet machine and the pilots who flew it with such deadly effectiveness. Part of the problem was simply ignorance, pure dangerous ignorance. Nobody in the West truly understood the MiG-21. Intelligence analysts had accumulated photographs taken by reconnaissance aircraft and satellites. They had radar signatures captured by monitoring stations around the world. They had performance estimates derived from careful observation of the aircraft during international air shows and military exercises. But all of this was essentially educated guesswork, extrapolation from incomplete data. No Western engineer had ever examined an actual MiG-21, no test pilot had ever sat in its cockpit and evaluated its handling characteristics through the full range of flight conditions. No radar specialist had ever opened up its avionics and traced the circuits that gave it the ability to find and track targets. Everything the West thought it knew about the MiG-21 was theory, and theory was proving inadequate when American lives were on the line. The consequences of this knowledge gap were measured in blood. Pilots were sent into combat without accurate information about their adversaries' capabilities. They were trained to use tactics based on assumptions that might be completely wrong. They were told their missiles would perform in certain ways against certain targets, predictions that often failed to match reality when it mattered most. The need to obtain an actual MiG-21, to touch it, examine it, fly it became one of the highest priorities for Western intelligence services. But how do you steal the most closely guarded aircraft in the communist arsenal? The Israelis had an idea. The Israeli Mossad had been wrestling with the MiG-21 problem since 1963. And their motivations were even more urgent than those of the Americans. The small Jewish state was surrounded by hostile Arab nations, every one of which was receiving advanced Soviet military equipment at an accelerating rate. Egyptian MiG-21s regularly probed Israeli airspace, testing reactions, gathering intelligence, demonstrating that they could strike at will. Syrian pilots flew the same aircraft from bases just miles from Israeli population centers. For Israel, understanding the MiG-21 threat was not an academic exercise or a matter of improved statistics. It was a question of national survival. A single successful air campaign by their enemies could be existential. They needed to know exactly what they were facing. The man who conceived Operation Diamond was Meir Amit, the director of Mossad from 1963 to 1968. Amit was a former military officer who brought a pragmatic, results-oriented approach to intelligence work. He understood that conventional methods would never deliver a MiG-21. The aircraft were too well guarded, too carefully controlled, too valuable to their operators. Stealing one from a hangar was effectively impossible. The security was overwhelming. Capturing one in combat would likely produce a wreck rather than an operational example. Amit's insight was elegant in its simplicity. The path to a MiG-21 ran not through hardware, but through human psychology. Somewhere in the vast network of nations operating the aircraft, there must be a pilot who is unhappy enough, ambitious enough, or desperate enough to be persuaded to defect. Finding that pilot and convincing him to bring his aircraft would require patience, skill, and an intimate understanding of human motivation. It was exactly the kind of operation at which Mossad excelled, turning human weakness into strategic advantage. The search for that pilot would take years, but Mossad had patience. What they lacked was time. The search began with a systematic effort to gather intelligence about MiG-21 pilots throughout the Middle East. Mossad operatives cultivated sources in every Arab Air Force, seeking information about individual pilots who might be receptive to recruitment. They were looking for specific psychological profiles, men who felt alienated from their governments, who had grievances that might be exploited, who possessed the combination of skill and courage necessary to attempt such a dangerous defection. The breakthrough came through an unlikely chain of connections that illustrated Mossad's remarkable ability to exploit diaspora networks. An Iraqi Jew who had emigrated to Israel maintained contacts within the Iraqi community through family members and friends who had remained behind. Through these connections, through whispered conversations and coded letters, Mossad learned of a pilot in the Iraqi Air Force named Munir Redfa, whose situation seemed promising. Redfa was a Maronite Christian, serving in a military establishment dominated by Sunni Muslims. Despite his exceptional flying skills and his obvious dedication to his profession, his advancement had been systematically limited by the religious discrimination that permeated Iraqi society. He had been passed over for promotions that went to less qualified pilots. He had been denied opportunities given freely to his Muslim colleagues. His family faced restrictions and indignities that were becoming increasingly intolerable. The intelligence about Redfa accumulated slowly over many months. Mossad operatives learned about his family's situation, his frustrations with the military hierarchy, his dreams for his children's future in a country that seemed determined to limit them. They discovered that he traveled occasionally to Europe for conferences and training, where he could be approached more safely than in the heavily monitored environment of Iraq. They identified his vulnerabilities and his desires, building a comprehensive psychological profile that would guide the recruitment effort. Now, they needed someone who could get close to him, someone Redfa would never suspect. They found her in an unlikely place. The initial approach was extraordinarily delicate. Any misstep could alert Iraqi counterintelligence and doom the entire operation. Mossad selected a female operative known by the cover name Betty to make first contact. She was beautiful, intelligent, and trained in the subtle arts of manipulation that could turn a chance encounter into a lasting relationship. Betty encountered Redfa during one of his European trips, engineering what appeared to be a chance meeting at a social event. She was charming and sympathetic, expressing genuine interest in his life and his experiences as a pilot. Over the course of several encounters spread across multiple trips, she cultivated his trust with patient skill. She listened to his frustrations, validated his grievances, and gradually steered conversations toward larger questions about his future and his family's welfare. The recruitment process took more than a year. Betty and other Mossad operatives worked in careful coordination, each playing a specific role in the psychological drama unfolding around Munir Redfa. They painted an increasingly attractive picture of life in the West, while simultaneously gathering detailed intelligence about his flying schedule, the aircraft he piloted, and the security procedures at Iraqi air bases. Every piece of information might prove crucial when the time came for the actual defection. Redfa was initially resistant to the ultimate proposition. Despite his unhappiness with his situation, he was a proud military officer who took seriously the oaths he had sworn. The idea of betraying his uniform, of becoming a defector, was deeply troubling to him. He understood that such an act would make him a traitor in the eyes of his country, would likely result in severe consequences for any family members left behind, and would define him for the rest of his life. The Mossad operatives addressed each concern with patient persistence. They emphasized that his true loyalty should be to his family, not to a government that treated him as a second-class citizen because of his religion. They described the opportunities that would await him in a new country, the chance to raise his children in freedom, the financial security that would be provided. They appealed to his pride as a pilot, emphasizing the historical significance of what he could accomplish, how he would be remembered as a man who changed the course of history. But Redfa remained hesitant. He needed something more than promises. Then came the night that broke him. Redfa returned home from the base to find his wife in tears. Their son, bright, ambitious, devoted to his father, had been denied admission to the military academy. Not because of his grades, which were excellent, not because of his physical fitness, which was exceptional, but because of his religion. The boy who had grown up idolizing his fighter pilot father, who had spent his childhood dreaming of following in his footsteps, would never be allowed to wear the uniform. In Iraq, some doors were simply closed to Christians, forever. That night, sitting in the darkness of his living room while his wife and children slept, Munir Redfa made his decision. He would take the offer. A decisive moment came when Mossad arranged for Redfa to secretly visit Israel through an elaborate sequence of movements involving multiple countries and cover identities. He was brought to Tel Aviv without the knowledge of Iraqi intelligence, passing through a series of carefully choreographed handoffs that left no trail. What he experienced during those few days transformed his thinking completely. Redfa found himself in a modern democratic society that bore no resemblance to the propaganda he had absorbed throughout his life. The Jewish state that he had been taught to hate was sophisticated and welcoming. Religious minorities lived freely, pursuing their careers and raising their families without the discrimination that blighted his own existence. Israeli officials treated him with respect, emphasizing that he would be welcomed as a hero if he agreed to the mission. The terms offered were generous. Redfa and his family would receive Israeli citizenship under new identities, protected from any Iraqi retaliation. He would be given a substantial financial reward, enough to live comfortably for the rest of his life. His children would receive excellent educations at the finest schools. Most importantly, he and his family would be free from the religious persecution that had limited their lives and crushed their dreams. Redfa agreed to the mission. But he insisted on one non-negotiable condition that would add enormous complexity to an already dangerous operation. His family must be extracted from Iraq before he made his defection flight. He would not leave them behind to face the consequences of his actions. He had seen what happened to the families of defectors: imprisonment, torture, execution. He would rather abandon the entire plan than condemn his wife and children to that fate. Mossad accepted the terms without hesitation. They understood that protecting defectors' families was essential not just for this operation, but for all future recruitment efforts. Word that Israel abandoned those who trusted them would make future approaches impossible. Reputation in the intelligence world was everything. Now came the hard part: getting his family out of Iraq without alerting anyone. The extraction of Redfa's family became an operation within an operation, requiring its own team of operatives, its own network of safe houses, its own carefully constructed cover stories. His wife and children had to be smuggled out of Iraq through a circuitous route involving multiple countries and numerous Mossad assets. The logistics were nightmarish: forged documents, bribed officials, backup plans for the backup plans. At any point, a single mistake could alert Iraqi security services and doom everyone involved. The Mukhabbara Iraqi intelligence was notoriously thorough and utterly ruthless. If they suspected anything, they would arrest everyone connected to Redfa and extract information through methods that didn't bear thinking about. The extraction took several weeks of nerve-wracking maneuvering. Redfa's family traveled in stages, never moving too quickly, never doing anything that might attract attention. A sudden vacation might raise questions. Too many purchases might suggest preparations for flight. They had to maintain perfect normalcy while their entire world was being secretly dismantled around them. They crossed borders using documents prepared by Mossad's expert forgers' papers, so perfect that even careful inspection revealed nothing amiss. They stayed in safe houses maintained by the organization's vast network of assets, moving only when signals indicated the next leg was secure. Never too fast, never attracting attention. It's always one wrong move away from catastrophe. Throughout those weeks, Munir Redfa continued flying routine missions from Rashid Air Base. He showed up for duty. He performed his assigned flights. He socialized with colleagues. He gave no indication that anything in his life had changed. The strain must have been almost unbearable, knowing his family was threading through hostile territory while he maintained the pretense that everything was normal. Finally, word came through encrypted channels. His family had reached Israel safely. They were protected. They were free. The time had come. Redfa's family was safe. The mission was on. But the most dangerous hour of Munir Redfa's life was about to begin, and it would be measured in minutes of fuel. August 16, 1966. Rashid Air Base, near Baghdad. Munir Redfa reported for duty like any other morning. He'd been assigned a routine training flight, an opportunity that Mossad handlers had helped engineer through months of careful manipulation of Iraqi military schedules. A word here, a suggestion there, pulling invisible strings until the right mission fell to the right pilot on the right day. He performed his pre-flight checks with the same professionalism he had always demonstrated, giving no indication that anything was unusual about this particular mission. Walk-around inspection. Control surface checks. Instrument verification. Everything by the book. Everything normal. When he climbed into the cockpit of his MiG-21, Redfa was carrying the weight of a decision that would change history. He strapped in, connected his oxygen, ran through the startup checklist one final time. Around him, the familiar sounds of an airbase coming to life, other aircraft starting up, ground crew shouting, vehicles moving on the tarmac. Startup sequence. Clearance from tower. Taxi to runway. The takeoff was routine. Full afterburner, rotation, gear up, climbing into the morning sky. He climbed to the assigned altitude and proceeded along the designated flight path, following the script that Iraqi controllers expected. Radio calls at the prescribed intervals. Heading adjustments as directed. Perfectly normal training sortie. Then he turned west and dropped. He pushed the MiG down until he was flying mere meters above the desert floor. At this altitude, he would be invisible to radar, hidden by the ground clutter that confused detection systems. His aircraft, just another ghost among the electronic noise of the terrain. He was also terrifyingly close to the ground, where any mistake, any lapse in concentration, any unexpected obstacle would be instantly fatal. For 53 minutes, Redfa raced across the empty wastes of western Iraq and Jordan. The altimeter needle barely flickered above zero. At this height, there was no margin. A moment's distraction, a single thermal updraft, a bird strike. The MiG would cartwheel across the desert floor at 600 miles per hour. His hands gripped the stick with white-knuckled intensity. His eyes flicked constantly between the horizon and his instruments, especially the fuel gauge. The needle had passed empty 10 minutes ago, was flying on fumes and faith. The flight was longer than the MiG-21's range would normally allow. Redfa had to manage his fuel consumption with extreme precision, constantly calculating and recalculating whether he would have enough to reach Israeli territory. Every unexpected headwind ate into his reserves. Every second of afterburner he'd used during takeoff was fuel he couldn't get back. Every deviation from the calculated route, however small, brought him closer to the moment when the engine would simply quit. The stress was unimaginable. One miscalculation, and he would flame out over the desert with no possibility of rescue. Even if he survived the ejection, he would be in Jordanian territory, surrounded by people who would happily return him to Iraq for whatever punishment awaited traitors. Israeli fighters intercepted him over the Negev desert, appearing alongside his aircraft to escort him to safety. The Mirage pilots who formed up on his wing had been waiting for hours, flying a racetrack pattern, wondering if the defector would actually appear, or if the whole operation had been compromised. The MiG-21 touched down at a military airbase with fumes in its tanks. Literally the last drops of fuel sloshing in the lines as the wheels kissed the runway. Ground crew would later estimate he had less than 2 minutes of flight time remaining. Munir Redfa had done it. I had completed one of the most audacious defection flights in aviation history. It delivered to the Western world the most valuable intelligence prize of the entire Cold War. Now came the question everyone was desperate to answer. What secrets did it hold? The Israeli Air Force immediately began an intensive evaluation program. Their best test pilots flew the aircraft through its entire performance envelope, documenting every characteristic with scientific precision. The handling qualities, the acceleration, the turning capability, the climb rate, everything was measured, recorded, and analyzed. Simultaneously, engineers began examining the aircraft's systems, taking detailed photographs and measurements of every component, creating technical drawings that captured every angle. What they discovered was both reassuring and alarming. A complex mixture of capabilities that defied simple characterization. The MiG-21 was everything they had feared in terms of raw performance. It was blindingly fast, capable of accelerating to Mach 2.1 in level flight, minus faster than any Israeli fighter then in service. Its climb rate was exceptional, allowing it to reach high altitude faster than anything in the Western inventory. In a close-range dogfight, its small size and excellent maneuverability made it a deadly adversary, able to get inside the turning radius of larger Western fighters. Israeli pilots who flew mock combat against the MiG-21 came away with profound respect for its capabilities. The aircraft was responsive and agile, able to reverse direction with startling quickness. Its acceleration was particularly impressive in the medium altitude bands, where most air combat took place. A pilot who knew how to exploit these characteristics could be extremely dangerous. But the evaluation also revealed significant weaknesses that had not been apparent from external observation. The aircraft's range was severely limited, restricting the distances at which it could operate effectively. Visibility from the cockpit was poor, with the heavily framed canopy and pilot positioning creating substantial blind spots, particularly to the rear. The radar system had limited capability compared to Western fighters, and the aircraft's handling characteristics became treacherous at high angles of attack, where it had a tendency to enter uncontrollable spins without warning. This information was invaluable for Israeli tactical planning. Now they could develop specific countermeasures, training their pilots to exploit the MiG-21's weaknesses while avoiding situations that favored its strengths. The intelligence translated directly into improved combat effectiveness for Israeli forces, knowledge that would prove decisive in the battles to come. But the Americans wanted their turn with the aircraft. The MiG-21 was killing their pilots over Vietnam in ever-increasing numbers. They needed this intelligence at least as desperately as the Israelis. Negotiations began almost immediately after the defection, with American officials pressing hard for access to the captured aircraft. The Israelis, recognizing the leverage they held, drove a hard bargain, extracting concessions that went far beyond the immediate matter of the aircraft. They wanted advanced military equipment, including items that had previously been denied to them. They wanted intelligence sharing agreements that would give them access to American information about their Arab adversaries. They wanted diplomatic support in international forums where Israel was increasingly isolated. The shopping list was extensive, and the Israelis negotiated with the skill of people who knew they held something priceless. The Americans, confronting a choice between their principles about arms transfers and their desperate need for MiG-21 intelligence, chose the intelligence. The aircraft was simply too valuable. The information it contained critical. American pilots were dying over Vietnam, and understanding the MiG-21 could save lives. In early 1968, the MiG-21 was secretly transported to the United States. The transfer was arranged with extraordinary security precautions. The aircraft was disassembled and shipped in unmarked containers, following a route designed to attract minimal attention. It arrived at Groom Lake, the secret test facility in Nevada that would later become famous as Area 51, where it was reassembled for evaluation by American engineers and test pilots. The program was codenamed Have Donut, and it became one of the most closely guarded secrets of the Cold War. Only a handful of people knew that the United States possessed an operational MiG-21. Security classifications were applied that exceeded even those used for nuclear weapons programs. Engineers who worked on the aircraft were required to sign strict secrecy agreements and were forbidden from discussing their work with anyone, including family members and colleagues not directly involved. The American engineers were about to get the surprise of their careers. The American evaluation team approached the MiG-21 with a mixture of curiosity and preconceived notions. They expected to find technology that was generally inferior to American systems, perhaps crude copies of Western designs, or indigenous developments that reflected the Soviet Union's supposedly less advanced industrial base. What they actually discovered would challenge these assumptions in ways that had profound implications for American military planning. The examination began with the aircraft's basic structure. Western engineers had assumed that Soviet aircraft would be roughly finished machines, reflecting the communist world's general reputation for poor manufacturing quality. American factories produced aircraft with precise tolerances and careful attention to detail. Soviet factories, according to conventional wisdom, prioritized quantity over quality, turning out large numbers of inferior machines. The MiG-21's airframe contradicted these expectations immediately. The construction was excellent, with precise tolerances and careful workmanship throughout. The aircraft's skin was smooth and well-fitted, with none of the gaps or rough edges that engineers had expected. Rivets were countersunk and finished with a tension that matched the best Western standards. The overall quality of construction was comparable to American fighters, a finding that forced immediate reconsideration of assumptions about Soviet manufacturing capabilities. The comfortable assumption of sloppy Soviet engineering died in the first hour of examination. Engineers examined the MiG-21's engine, the Tamansky R-11 afterburning turbojet, with particular interest. This power plant was the heart of the aircraft's remarkable performance, the source of its blistering speed and exceptional climb rate. American engineers had estimated its characteristics based on observed aircraft performance, but they had never examined the actual hardware. The R-11 confirmed some expectations, while overturning others. It was not as fuel efficient as comparable American engines, which explained the MiG-21's limited range. Soviet engine technology lagged behind American capabilities in this regard, but the engine produced enormous thrust for its weight and size, delivering the raw power that gave the aircraft its exceptional acceleration and climb performance. More importantly, the engine's design prioritized simplicity and ease of maintenance in ways that American engines did not. The R-11 could be completely removed and replaced in under 2 hours by a trained crew using minimal specialized equipment. This was dramatically faster than the time required to service comparable American engines, which often demanded extensive disassembly, specialized tools, and highly trained technicians. In a prolonged conflict where aircraft would need rapid turnaround to maintain operational tempo, this maintenance advantage could prove decisive. An air force that could return damaged aircraft to service quickly would maintain higher sortie rates than one forced to wait for complex repairs. Soviet designs anticipated this requirement in ways that American designs did not. The examination of the MiG-21's weapon systems produced additional findings that complicated Western understanding of Soviet capabilities. The aircraft carried a twin-barreled GSH-3 cannon and various air-to-air missiles, including the K-13 that NATO designated the AA-2 atoll. The K-13 was no mystery to Western intelligence. They knew it was based on an American design, the product of a remarkable intelligence coup that had occurred years earlier. In 1958, during aerial combat between Taiwanese and Chinese aircraft over the Taiwan Strait, Taiwanese F-86 had fired a Sidewinder missile at a Chinese MiG-17. The missile had failed to detonate, but had embedded itself in the MiG's airframe. The Chinese pilot, remarkably, had managed to land his damaged aircraft, and the intact Sidewinder had been recovered and shipped to the Soviet Union for analysis. Soviet engineers had reverse-engineered the American weapon with impressive speed, producing their own version within 2 years. The K-13 was the result, and American analysts had assumed it was a crude copy that did not match the performance of the original. The examination of actual K-13 missiles recovered with the MiG-21 showed this assumption was wrong. The Soviet version had been improved in important ways. The infrared seeker head was more resistant to countermeasures, particularly the flares that American aircraft used to decoy incoming missiles. The rocket motor was more powerful, giving the missile greater range and better endgame maneuverability. The warhead was larger, increasing the probability of a kill when the missile reached its target. The K-13 was not merely a copy of the Sidewinder. It was an evolution, incorporating lessons learned from studying the American design and improved by Soviet engineering expertise. This finding undermined the comfortable assumption that Soviet weapons were always inferior copies of Western originals. The cannon installation was equally impressive. The GSH-3 was a gas-operated twin-barreled weapon capable of firing 3,400 rounds per minute. Its placement and mounting showed careful attention to accuracy and reliability. Test firings demonstrated the weapon was at least as effective as comparable American cannon, with excellent accuracy and consistent performance. But it was the avionics, the electronic systems, that gave the aircraft its fighting capability, that produced the most significant and surprising revelations. American engineers had expected to find sophisticated miniaturized electronics similar to those being developed in Western laboratories. The trend in American technology was towards smaller, lighter components that could pack more capability into less space. Surely the Soviets were pursuing the same approach, probably with less success, but along the same general lines. What they found instead was something completely different. A design philosophy that initially seemed primitive gradually revealed itself to be far more clever than anyone had anticipated. The examination of the MiG-21's radar system illustrated this perfectly. The RP-21 SAP-4 radar was carefully removed from the aircraft's nose cone and transported to a secure facility for detailed analysis. Engineers began disassembling it piece by piece, photographing and documenting every component, tracing the circuits that allowed it to detect and track targets. This was the moment they had been waiting for, their first look inside Soviet fighter electronics. What they saw made no sense. Vacuum tubes. Dozens of them. Same technology that powered radios in World War II, instead of the tiny integrated circuits and compact, solid-state components that characterized American systems. The Soviet radar relied on vacuum tubes and large discrete electronic components. By Western standards, this seemed like hopelessly outdated technology. Vacuum tubes had been replaced by transistors in American electronics years earlier. Using them in a frontline fighter seemed like equipping a modern army with muskets. The engineers exchanged glances. This had to be some kind of joke. Initial reports were almost gleeful. Soviet electronics, primitive, at least a decade behind Western capabilities, confirms technological superiority of American systems. The engineers congratulated themselves on the confirmation of everything they had believed about communist backwardness. Then someone asked the question that changed everything. Why? The Soviets had transistors. They had demonstrated solid-state electronics at international conferences. They had the capability to miniaturize. So why would they deliberately choose obsolete technology for their frontline fighter? Why would they accept the weight penalty, the space penalty, the power consumption of vacuum tubes when they could build something smaller and lighter? The answer, when it came, sent a chill through every engineer in that room. Vacuum tubes survive electromagnetic pulse. EMP, the massive surge of electromagnetic energy generated by nuclear explosions. A nuclear detonation produces an EMP that can destroy solid-state electronics at considerable distances from the blast itself. Aircraft flying anywhere near a nuclear battlefield would be bathed in electromagnetic energy that could fry their sophisticated computer systems in an instant. American aircraft, with their advanced solid-state avionics, would be particularly vulnerable to this effect. A nuclear exchange would likely ground most American fighters, leaving them unable to navigate, unable to communicate, unable to employ their weapons. The sophisticated technology that gave American aircraft their edge in normal combat would become their fatal weakness in nuclear war. Soviet aircraft with their vacuum tube avionics would keep flying. Their electronics would survive the EMP that destroyed American systems. In the nightmare scenario of nuclear conflict that both superpowers spent every waking hour planning for, the seemingly primitive Soviet technology would prove superior. Their pilots would still have radar, still have navigation, still have weapons guidance. While American aircraft sat useless on runways or fell from the sky with dead electronics, the Americans hadn't been looking at Soviet backwardness. They had been looking at Soviet preparation for nuclear war.
This realization sent shockwaves through the American defense establishment. The United States had been investing heavily in miniaturization and solid-state electronics, assuming that smaller and more sophisticated was always better. Nobody had adequately considered what would happen to these delicate systems in the electromagnetic environment of nuclear war. The Soviets had thought about it, and they had made different choices accordingly. The implications extended far beyond aircraft. American missiles, ships, command centers, and communication systems all relied on solid-state electronics that would be vulnerable to EMP. The entire American military machine might be crippled by effects that Soviet systems were specifically designed to survive. This was not a minor technical finding. It was a fundamental strategic revelation that forced reconsideration of American assumptions about nuclear warfare. The deeper the analysis went, the more uncomfortable truths emerged. The radar system itself, despite its seemingly primitive construction, proved more capable than expected. American engineers had anticipated finding a system with limited range and poor resolution, adequate perhaps for basic interception work, but inferior to Western systems in every measurable parameter. What they found was different. The RP-21 could detect fighter-sized targets at ranges exceeding 20 kilometers in optimal conditions. Its tracking capability was sufficient for guiding the aircraft's weapons to their targets. The system was simple and rugged, with far fewer components than comparable American radars, which meant fewer things that could fail under the stresses of combat operations. The simplicity was itself a feature, not a bug. American radars were sophisticated instruments that required careful maintenance by highly trained technicians. They were sensitive to heat, vibration, and humidity. They needed regular calibration and adjustment. They were, in short, temperamental machines that demanded constant attention. The Soviet radar was designed for different circumstances. It could operate in the harsh conditions of forward air bases with minimal maintenance facilities. It could tolerate the rough handling that was inevitable in high-tempo operations. It was designed to be repaired in the field by technicians with basic training, rather than requiring specialized expertise available only at major bases. This design philosophy reflected Soviet strategic assumptions. The Soviet Union anticipated fighting a massive conventional war in Europe, with thousands of aircraft operating from austere forward airfields under constant enemy attack. Sophisticated equipment that required extensive maintenance would be useless in such circumstances. The Soviets needed systems that could keep working despite everything the battlefield could throw at them. The cockpit examination produced findings that helped explain both the MiG-21E's effectiveness and its limitations. American evaluators spent hours in the cockpit, studying the instrument layout, the control arrangements, and the pilot's working environment. The instrument panel was simple by Western standards. Analog gauges displayed basic flight parameters. There was no sophisticated navigation system, no computer-generated displays, minimal automation of any kind. Soviet pilots were expected to perform mental calculations that American aircraft computed automatically. They had to manage their flights with less assistance, relying on skill and training rather than technology. This approach had obvious costs. Soviet pilots had to be better trained in certain fundamental skills because they could not rely on automated systems to assist them. Their workload in combat was higher because they had to track information that American cockpits displayed automatically. These factors placed a premium on pilot quality in ways that could be difficult for the Soviet system to meet. But there were benefits as well. The simple cockpit was less likely to fail in critical ways. An American aircraft with a malfunctioning computer might be seriously compromised, unable to navigate or employ weapons effectively. A MiG-21 with a gauge failure would still be fully flyable. The Soviet approach traded capability for reliability in ways that made sense given their operational assumptions. The cockpit's most significant limitation was visibility. The heavily framed canopy provided structural strength but created substantial blind spots. The pilot's seating position, optimized for control during high-speed flight, made it difficult to check certain sectors around the aircraft. American test pilots who flew the MiG-21 noted that they felt vulnerable to attack from behind, unable to see threats that would have been visible in American fighters. This weakness could be exploited tactically. American pilots, informed by the evaluation findings, could position themselves in the MiG-21E's blind spots and press attacks from angles where they were unlikely to be detected. The knowledge was directly applicable to combat operations in Vietnam, where American aircraft were engaging MiG-21s regularly. The ejection seat was another area of intense interest. Soviet ejection technology had been a mystery to Western analysts. The MiG-21 seat proved competent, representing genuine innovation in certain respects. It could be used at zero altitude and zero speed, allowing a pilot to escape from an aircraft that had lost power while still on the ground, a capability that had not been available in earlier Soviet aircraft. The overall assessment painted a picture of a design philosophy fundamentally different from American approaches. Soviet aircraft were not simply inferior attempts to copy Western designs. They represented different answers to different questions, reflecting different strategic assumptions and different operational requirements. American aircraft were optimized for maximum individual capability. They were designed for pilots who would receive extensive training and fly limited numbers of sorties from well-equipped bases with comprehensive maintenance support. They incorporated the most sophisticated technology available because such technology could be supported. In the American system, Soviet aircraft were designed for different circumstances. They anticipated mass production and operational deployment under conditions that would be austere by American standards. They prioritized ruggedness and simplicity over sophistication because sophisticated systems would be difficult to maintain in the field. They were designed for pilots who might receive less individual training but would operate as part of larger formations where numerical superiority could compensate for individual limitations. Neither approach was objectively superior. Each reflected the strategic circumstances and industrial capabilities of its parent nation. Understanding this was crucial for American planners who had been making decisions based on assumptions of Western superiority that did not hold across all relevant dimensions. The comfortable assumptions were dead. Now came the hard work of adapting. The intelligence gathered from the MiG-21 evaluation was immediately applied to improve American combat effectiveness. Pilots were briefed on the specific handling characteristics of the aircraft, learning exactly where it was dangerous and where it was vulnerable. They discovered that the MiG-21E's high-altitude performance was exceptional, but that its maneuverability decreased significantly at lower altitudes. They learned that the aircraft's acceleration was most impressive at medium altitudes, but fell off at both extremes. Training programs were revised to incorporate these findings. American pilots practiced engagements against profiles that reflected actual MiG-21 performance rather than theoretical estimates. They learned to exploit the visibility limitations of the Soviet cockpit. They developed tactics that avoided the MiG-21E's strengths, while attacking its weaknesses. The most important application was the establishment of dissimilar air combat training using the captured aircraft itself. For the first time, American pilots could practice against an actual MiG-21 rather than American aircraft attempting to simulate MiG performance. The Have Donut program eventually expanded to include regular training exercises where Navy and Air Force pilots flew their frontline fighters against the captured Soviet aircraft. These exercises produced immediate tactical benefits that translated directly into improved survival rates over Vietnam. Pilots who had trained against the real MiG-21 knew exactly what to expect in combat. They recognized the situations that favored the enemy and avoided them. They identified opportunities to exploit the aircraft's weaknesses and acted on them decisively. The technical intelligence influenced American aircraft development programs for decades. The F-15 Eagle, which would become America's premier air superiority fighter, incorporated specific lessons learned from the MiG-21 evaluation. Designers ensured superior visibility from the cockpit, directly addressing one of the Soviet aircraft's most significant weaknesses. They provided greater fuel capacity to ensure range advantages. They specified performance characteristics that would exceed the MiG-21E's capabilities across the entire flight envelope. The revelation about electromagnetic pulse resistance had profound implications that extended far beyond aircraft design. American engineers began crash programs to develop hardened electronics that could survive the effects of nuclear explosions. This research produced technologies used not only in military aircraft but in missiles, satellites, command systems, and critical infrastructure throughout the American military establishment. The Soviet design philosophy that had initially been dismissed as primitive was recognized as addressing a vulnerability that American planners had dangerously overlooked. The comfortable assumption that American technology was always superior had been replaced by a more nuanced understanding that different technologies made different trade-offs, and the optimal choice depended on the circumstances of employment. Israel continued to benefit from its role in Operation Diamond. The captured MiG-21 was flown extensively by Israeli pilots who developed comprehensive tactical knowledge of the aircraft. When the Six-Day War erupted in June 1967, Israeli pilots knew exactly how to fight against the MiG-21 as they encountered in the skies over Egypt and Syria. The results were devastating for Arab air forces. Israeli fighters shot down dozens of enemy aircraft while suffering minimal losses themselves. The tactical advantages provided by the MiG-21 evaluation were directly reflected in combat outcomes. Pilots who understood their enemy's capabilities could fight with confidence and precision. Israel eventually obtained additional MiG-21s through other means, including aircraft abandoned on airfields captured during the Six-Day War and subsequent conflicts. These aircraft were added to the evaluation program, providing additional examples for analysis and training purposes. The flow of intelligence continued for years, helping to maintain Israeli air superiority throughout the turbulent period of Arab-Israeli conflict. Munir Redfa received everything he had been promised. He and his family settled in Israel under new identities, protected by security arrangements that would keep them safe from Iraqi revenge. He received a substantial financial reward that allowed him to live comfortably for the rest of his life. His children attended good schools and grew up as Israelis, free from the discrimination that had plagued their lives in Iraq. But Redfa never flew again as a military pilot. The exceptional skills that had made him valuable enough to be recruited, his extraordinary ability in the cockpit of high-performance aircraft, were never employed after that final flight from Baghdad. He lived quietly, known only to a small circle of intelligence officers who understood the magnitude of what he had accomplished. The man who delivered one of the Cold War's greatest intelligence prizes spent his remaining years in obscurity, watching from afar as the consequences of his decision rippled through history. Operation Diamond remained classified for many years. Hints of the story leaked out over time, but the full details were not revealed until decades after the events occurred. By then, the MiG-21 itself had become obsolete, replaced by newer generations of Soviet fighters, but the lessons learned from examining it continued to influence military thinking long after the specific aircraft had been retired. The operation demonstrated fundamental truths about intelligence work that remain relevant today. It showed the value of patient long-term effort, the willingness to invest years in cultivating a single asset who might ultimately prove decisive. It illustrated the importance of understanding human psychology, the ability to identify individuals whose circumstances made them susceptible to recruitment and to approach them with the right combination of incentives and appeals. Most importantly, Operation Diamond showed that the most valuable intelligence often comes not from technical collection methods, but from human sources willing to take extraordinary risks. Satellites and signals intelligence could provide useful information about Soviet aircraft, but nothing matched the value of an actual example that could be examined in detail. Getting that example required finding and recruiting a human being willing to betray his country for personal reasons. The technical evaluation demonstrated equally important lessons about military technology and the dangers of assumption. American engineers had approached the MiG-21 with preconceived notions about Soviet capabilities that proved largely wrong. Their assumptions of Western superiority had blinded them to the possibility that Soviet designers might have made different but equally valid choices. The vacuum tube avionics that initially seemed primitive turned out to address a critical vulnerability that American designers had ignored. The simple construction that appeared crude proved to be deliberately optimized for conditions that American aircraft could not handle. The weapons that were assumed to be inferior copies turned out to be genuine improvements on the original designs. These findings forced a fundamental reassessment of how American analysts thought about Soviet technology. The comfortable assumption of across-the-board Western superiority was replaced by a more sophisticated understanding that recognized Soviet strengths as well as weaknesses. This more accurate picture was essential for sound strategic planning and for the development of systems that could actually defeat Soviet weapons in combat. The MiG-21 sits in museums today. Visitors walk past without a second glance, just another Cold War relic. Its secrets long obsolete, its technology surpassed a dozen times over. But those who know its history see something else. They see a lesson written in vacuum tubes and riveted aluminum, that the enemy is never as simple as you want them to be, and that the assumptions you don't question are the ones that get people killed. Somewhere in a classified facility right now, engineers are examining captured equipment from a new adversary. One hopes they remember what their predecessors learned when they opened up that MiG, that the most dangerous discovery isn't finding your enemy is stronger than you thought, it's finding out you never really understood them at all.